For science fair projects, we use standard error to show how much variation you would naturally expect from any experiment that had the same number of trials as you had and resulted in the same results. Like, it helps you determine how significant your results are. So what we would do is find the standard error, and you're going to use the standard deviation to do that. After you find the standard error, you you make that be a range above and below your experimental and control group means. So let me just show you what that means. You'd see if there's any kind of an overlap. So let's see, here's my little thing. I'm going to show you what I mean. Let's say that you had a control group and its results, the average was 10, I don't know, 10 centimeters or something. And let's say your experimental group, its average was 15. I don't know, maybe these are how long a snake grew or something, I don't know. And let's say the error, though, on your experiment was, let's say, very small, 0.5. That means that on average, any other experiment set up like yours with the same number of sample sizes would tend to have 9.5 to 10.5 as a range of expected results. And the experimental group would have, okay, plus or minus the same error, let's say 14.5 up to 15.5. Those would be expected variation in your results. So maybe the next time you do this experiment, you'd get 9.5 and 15.5 as your results. That would be normal and expected and not surprising. So what we do is we look at, is there any overlap here? Like the highest, okay, look at the two numbers. 10 is lower than 15. The highest it could normally fluctuate up with this standard error is 10.5. And look at the higher number, 15 for that mean. The lowest it would normally fluctuate down would be 14.5. So on average, done 100 times, this very same experiment that you did would probably not result in overlap of these results. The highest would probably be about 10.5, the lowest would be about 14.5 for the experimental group, so there's no overlap. And so what we would say is these results are significant. The results are significant, and so this helps us determine whether or not there's actually a correlation between the independent and dependent variables. I can't spell and write. Significant. But if the error were large, like let's say, I don't know, 9, then here, the control group, it could have been anywhere from 1 to 19, and the experimental group could have been anywhere from 6 to, add 9, 24. Well, there's a lot of overlap there in that 6 to 19 range. So you would say those results are not significant, that we got 10 and 15 this time. I mean, any other time it could have been 1 and 24, and so it wouldn't be any surprise that you got 10 and 15. So then we would say the results are not significant. So the question is, how do you find standard error now that we realize it's so important? And there's a formula for it. Standard error is just determined by taking the standard deviation, which you can calculate, and dividing it by the square root of n, and n is just the number of items, or number of trials, number of numbers really. It's the sample size, number of trials, number of numbers that you average together. So that's how you calculate standard error. And then there's a way to do it in Excel, which I'm hopefully going to show you. This right here is a program or a spreadsheet I made of just a sample percent of fertilizer added, and I can see I'm kind of running out of time. I don't know if I'm going to get to this, but just quickly, I don't think I can do this quickly. I'm going to do it on another video.